Alright, it's Tristan Bosman, and today I'm going to give you a quick tutorial on how to use FEA in ANSYS. So I'm going to be analyzing my capstone design, which is a motorcycle downforce generator. It has 5 airfoils mounted radially from the hub of a front wheel. First thing you're going to want to do is save it as an IGES file, which is the native resolution for ANSYS. What you're going to want to do after that is open ANSYS. I've done a little bit to kind of expedite the process, but you would import your file that you just saved, and then you can it'll pop up this little box here. You can right click on the geometry, edit it, and unfortunately I did not center my assembly on the coordinate system when I made it in SOLIDWORKS, but luckily we can change that fairly easily. So we'll create a body translation. We need to select all of the body parts, so drop down the menu. You can shift click to select them all and hit apply. Sees that it has 55 body components. So next thing, direction definition. You can hit this drop down menu, coordinates, and I've already calculated these from my SOLIDWORKS file, so negative 3.81, negative 8.85, and negative 15.99. And now you'll hit generate. You'll hit that button a lot. So it's centered on the x-axis now, and because it's symmetrical, we can take advantage of that by creating 2 planes and telling ANSYS that it's symmetrical about those planes. So you can right click on your import geometry, insert new plane. It defaults to XY, which is actually the one that we want. So the transformation we want is a rotation about the X, which is perpendicular to the wheel itself. You can't see it right now, but it is. So that's going to be 288 degrees. Generate that. The wheel should come back in a sec. Yep. Then we're going to want to insert another plane. That's going to be offset from the plane we just made, which is plane 12. It automatically selects that. So we want to rotate about the X again. This was 252 degrees, and these numbers could always be different for any design, but you'll have to do a little bit of math to figure out where the plane should be. So next we'll go into Tools, Symmetry. We want to select 2 planes. So click in the plane 1 box, select one of your planes. Click in the other box and select the plane you did not select the first time, and hit generate, and it should make 4 of, yep, they disappeared. So now it knows that it's symmetrical about these faces. So now that we have our geometry figured out, we can close out of this. And what we do now is come over to this left side, and it gives you all the types of analysis you can do. We want static structural, so you would drag this over here. It's already there because I did it. And these boxes will be blank, but to link the geometry, you would click this and hold down the left click and drag it over to box number 3 here, and it'll automatically fill in those. So we know that our geometry is what we want to be. We can right click on model and hit edit. It's going to need to refresh the data that it already had. So down here you could see that it was working on starting this model. It's still trying to work. So any day now it should be done, and it is. So what we're going to want to do now is build a mesh for the FEA. So for now we'll go automatic method. We need to select all the bodies, and the easiest way to do that is control click all of the components in your drawing. And hit apply. It'll turn them purple so that you know you have everything selected, and you can change the type of method you want. For now we'll just do automatic. You hit update mesh and it will do its thing. So by clicking on the mesh you can see what it looks like. If you know that you're going to have problematic areas, you can right click on mesh, insert a sizing, and select the components you want to have a smaller mesh. So for now we'll do the 2 connecting rods. Hit apply, select those bodies, and give it an element size. And then update your mesh again. So as you can see, it made those way smaller than they were to start with. On the academic versions on campus, you can have up to 256,000 nodes and elements. You can see that value by clicking on your mesh, coming down to the drop-down menu for statistics, and the values are right here. I'm on my home computer, which is the student edition of ANSYS, and you have a limit of 32,000 nodes and elements, which really isn't enough to do a proper analysis on anything. I actually can't even get this mesh small enough to be below those values. But what you do now is come to your static structural. You can insert forces, boundary conditions. So for now we'll go frictionless support on both sides of the rim, because usually there would be spokes here holding this from deforming in the X direction, but they're not there, so we can fix that. We can also input a cylindrical support that will go on the inside of the hub and not let it translate in the Y or Z directions. We can insert our pressure or forces, so our pressure of lift was calculated to be about 3.5 psi, so we'll select our airfoil, apply. We'll go to components, because if we do normal to, it will follow the profile of the airfoil. So 3.5. We'd also need to put our drag in, but we'll neglect that for now. And then in solution, you right click on that, insert whatever you want to test. So we'll do equivalent von Mises stress. And what you do now is you would tell it to solve it, but because I'm on the student edition, I can't do that. So I'll show you my results from when I complete it on campus. So this is what my mesh looked like. I had basically maxed out the 250,000. The max stress was where we expected at the top connecting rod. It was a value of about 140 KSI, and here's a close-up view of it. So hopefully this will help someone in the future.